Lesson 85, systems of nonlinear equations. All we've been doing lately is graphing linear equations. Okay, these are systems of equations where we're graphing lines. All right, so now we're going to be talking about nonlinear equations. All right, so let's define. A nonlinear equation is equations whose graphs are not straight lines. Now, there are a lot of different types of nonlinear equations. A lot of these are called what we would call conic sections. We're not going to talk about how to actually graph them, but instead we're going to use substitution and elimination to solve for the system of equations. All right, there are a lot of different kinds of conic sections, especially when you get to calculus and pre-calculus. You're going to be learning how to graph a lot of these, which is why it would be a good idea to go ahead and get a graphing calculator. But some different kinds of conic sections. You have circles, ellipses, parabolas, hyperbolas. You can also make a bunch of different fun shapes, but we'll talk about those when you get into some of the higher maths. All right, I already said that we're going to be using these, solving these using substitution and elimination. The thing that we need to remember about nonlinear equations is that instead of there being one system of solutions, there are going to be two sets of solutions. All right, how do we know the difference between a nonlinear equation and a linear equation? Nonlinear equations deal with quadratics, all right? So any quadratic is a nonlinear equation. All right, remember quadratics include any x terms that are squared or any y terms that are squared. All right, so we're going to talk about how to solve systems of equations. Again, we said it was by substitution or elimination, so let's look at an example. We have x squared plus y squared equals 9, and 2x minus y equals 3. All right, now the only way we can do this is by substitution, unless you want to go through and square it, which is going to end up being really complicated to use elimination. All right, so we're going to substitute. In this equation, I'm going to solve for y in the bottom system. All right, I'm going to subtract 2x from both sides. And then if I go back through and change all of my signs, I'm going to get y equals 2x plus 3. All right, so in my first equation, in place of y, I'm going to put 2x minus 3. So I have x squared plus 2x minus 3 squared equals 9. All right, we're going to have to go ahead and square that binomial, which means you're going to have to use the distributive property. All right, so we have 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is 9. All right, we're going to go ahead and add that to our x squared term and set it equal to 9. All right, now we can go ahead and combine like terms to solve. X squared plus 4x gives me 5x squared. Negative 6x minus 6x is negative 12x plus 9 equals 9. All right, if I subtract 9 from both sides, I'm going to get 5x squared minus 12x equals 0. Now, you can solve this by either factoring or you can use the quadratic formula. You can complete the square. I'm going to factor. All right, in this case, I'm going to factor an x out. So I get x and then 5x minus 12. All right, so one of my solutions is that x equals 0. So I have x equals 0. And then if I set 5x minus 12 equal to 0, I'm also going to get that x equals 12 fifths. All right, notice that you have two solutions for x, which means that you're also going to have two solutions for y. So when you're substituting back in to find an answer, you're going to have to substitute it back in twice. All right, if I substitute 0 in for x, all right, I'm going to have 0 squared plus y squared equals 9, which means that y equals 3. So when x is 0, y is equal to 3. So that's one answer, one solution. And then when I substitute 12 fifths in my equation, I'm going to solve and figure out that y is equal to 9/5. All right, and you can substitute it back into either equation. It doesn't matter, just choose which one would be easier for you. All right, so anytime you graph a nonlinear equation, you're going to get two solutions. All right, let's look at an example just to review for a linear equation. If I have x plus 5y equals 25 and x minus 5y equals 15. All right, I can use elimination and eliminate my y values and get 2x equals 40, which means that x equals 20. All right, since I've only gotten one solution, we know that this is a linear equation. And if I plug this back in, I'm going to get y equals 1. So there you see the difference between the two. All right, now that we've looked at those two, we've got one that was linear and one that was nonlinear. I'm going to go ahead and put two equations on the board. One is a linear equation. One is a nonlinear, okay? So remember, for the linears, you're going to get one set of solutions. For the nonlinears, you're going to get two. All right, so the first one, I have x plus 9y equals 36, and x minus 9y equals 18. For my second one, I have x squared plus y squared equals 25, and 2x minus y equals 5. All right, on your own, go ahead and solve those two. One is linear, one is nonlinear. Go ahead and tell me which one is linear and which one is nonlinear, and we will check them when we come back into class.